Okay, so yesterday you guys learned about a bunch of different log properties, okay? Things that we're allowed to rewrite logarithms using, and it ends up resulting in these two things called expansion and condensing, okay? Expanding and condensing. We're going to focus today on just looking at some expanding problems. Again, you saw some of these yesterday with the log properties, but I want to kind of show you how to apply those properties in order to rewrite some of these log expressions that you're looking at, okay? So for example, I have two problems here. The first one is the log base 3 of 10 times z, okay, or 10z. This would all be within the log base 3, okay? So what we can do is using our properties that you learned about yesterday, we actually can go ahead and start to rewrite some of these to look in a different way. And sometimes it'll help us do different things, but right now our goal is just to expand it as much as possible. I like to think of it as, pretend this is all nice and bundled up in a suitcase. We're going to try to expand it as much as possible, get everything out of the suitcase that we can, okay? So one thing that we know, because these are multiplied, when things are multiplied inside your logarithm, you can actually rewrite them so that they're being added together, okay? So I can actually rewrite this as the log base 3 of 10 plus the log base 3 of z. Okay, that is an example of expansion. I'm using that property. When things are multiplied, I can rewrite them as being added together, and I'm using that to expand it out, okay? Now, this actually is about as far as this can expand. We don't have any other properties we can apply. The only thing we could do is that we could say what the log base 3 of 10 equals, but it's going to be some gross decimal, so it doesn't really help us out. So this would be my final answer, okay? So again, we expanded it by using that property, expand it out. Now, I started with a really simple one. Let's get to a much more complicated one. Here, we have the natural log of the square root of x squared divided by y squared, okay? So the first thing I'm going to do is I see the square root, okay? I know that the square root is really the same thing as rewriting this to the 1/2 power. Remember, roots are fractional exponents. So really my problem more looks like this. And knowing this, one of the properties was that if we had an exponent, we can move it down in front of our logarithm. So I can rewrite this as 1/2 times the natural log of x squared divided by y squared, okay? Another property that we know is that if we see division, that's the same thing as subtracting two logs with those insides. So we're going to change this and rewrite it as 1/2 times the quantity of the natural log of x squared minus the natural log of y squared. Okay, so again, I'm applying my logarithm properties. I got rid of this 1/2, moved it out front. I now go ahead and rewrite this like this. And now I can go ahead and say, oh, look, I have more exponents. Again, exponents can come out front. So this can be 2 natural log of x minus 2 the natural log of y. Last thing I can do is just to do some simplifying that we already kind of know how to do. In this case, I can distribute this 1/2. So if I multiply each of these by 1/2, I'm going to get the natural log of x minus the natural log of y. Okay? And that would be my final answer. Here is this expression fully expanded out. Okay? Again, our goal is to try to rewrite this in a different form, and we're doing that by applying our log properties and using them to expand this out as much as possible. Take everything apart as we go. Okay? Let's do one more example. Let's do this one. Let's do the log, and we'll do log base 10. So we'll just write the log of 4x squared y. Okay? So again, I'm going to apply my log property of when things are being multiplied. That's the same thing as adding those logs together. So I can say that this is equivalent to the log of 4 plus the log of x squared plus the log of y. And now that I look at these things, I say, hey, you know what? When I have an exponent, that can come down in front. So I get the log of 4 plus 2, the log of x plus the log of y. With doing this expansion, what you're going to notice if you have multiple things kind of going on is that the first thing you're going to try to do is you're going to basically kind of almost work, do PEMDAS backwards. You're going to get rid of your multiplication, expand that out, then get rid of your exponents, and then do anything else you have to do. The one thing that you need to do first, though, is any thing that's overtaking the whole thing, any sort of parentheses is what I would say. So like this square root, because it's over the entire thing, I have to move that out first. Then I can start looking in here and go, okay, get rid of this division by doing the subtraction, then get rid of the exponents by bringing those out front. Okay? But this will be your final answer. Again, what we are doing is we're rewriting these, expanding them out, rewriting them as a different expression by using these logarithm properties. And your goal today, with all the problems you're going to see, is to do expansion. Okay? You're going to be working from the smaller thing to the larger thing. So my advice for you is when you go to do your problems today is to have your notes out from yesterday. You should have all the logarithm properties out in front of you so you can look at them as you go through this. If you want to know where they are in the book, the logarithm properties are on page 406. Okay, so you can see them there as well. And what you're going to be doing is you're basically working from the smaller thing to the larger thing. You're expanding them out. Okay, thank you all for watching.